Hello, all agents. I'm Walker Stipe. Yo, what up? We're going to talk about GANs. Why? Because we need to talk about GANs. Like, really need to do that. So, question 1. That's lighthearted and super chill. Is truth dead? First off, what do the GAN? What is a GAN?
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you.
You take the blue pill. The story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill. You stay in Wonderland. And I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more.
This is Annnnd Goodfellow. We're going to talk about him a lot because he is A, goddamn fucking badass, and B, dangerous. I forgot what B was. He's dangerous because he's too smart. He's too smart. Nuclear weapons are too powerful. Gene editing, gain-of-function gene editing is too dangerous and shouldn't be done, ever. This is Annnd Goodfellow. Why are we talking about this funny man with a little twirly-do hat working at Noogle? Because this is the guy who invented GANs. It's just him. No, it's not like a team. It's not Google. It's not DeepMind. It's not OpenAI. It's not Baidu. It's not the Chinese government. It's just this guy. Silly hat. Just one guy. Okay. So, Annnd Goodfellow was out at the bar, being a good fellow, as a PhD, I was going to say grad, but a graduate, whatever. He's at the bar with his buds, and they're talking about different ways to, use artificial intelligence to generate, in particular, images. And he's like, well, yeah, you could do it like this, describing the basic structure of a GAN. And his friends are like, no, you can't. It's like, I might be a little bit tipsy, but I'm going to go home, and I'm going to make it. So what did Annnd do? Well, he went home, and he fucking made the first GAN in the year, at least 2016. 2016 is when the paper came out. I don't know the exact timeline. At least 2016, maybe slightly before. And long story short, we now have GANs. They're now incredible. Jan LeCun, a big wig in the AI industry, has stated they are like the biggest step forward in AI in recent years. GAN is basically an AI neural network that is generating pictures. It can be used for other stuff, but that's not the point we're doing here. Currently, just pictures, video, or a sequence of pictures. So you have this thing called a generator. That's the neural net that's making stuff. Okay? And then you have the discriminator. And these are considered one thing, but they're separate entities. Not getting too much into the architecture of a neural network for for the time being. This is not a technical video more than it needs to be. Hopefully it doesn't need to be that much. Okay, so your generator's making shit. Your discriminator is telling, it's determining, it's discriminating, how dare it, whether or not the pictures that your generator is making are bullshit. That's its job. So basically, it's given an image. And the image could be legit, could be a real picture, or it could be a piece of phony fakery. Which still does that process a lot, and it gets better, starting from random noises we see here, and eventually it shits out the kind of stuff like we saw earlier with Jim Carrey and Neo. A less boring fucking fact example and a more spicy habanero example would be a spicy Joker who's making stuff. He's got these plans and he's producing things into the world. And the discriminator, a Sherlock Holmes type character who's trying to figure out what the hell the bad guy's up to and whether or not the stuff he's making is legit. So, on the one hand, you have the forger, who is John Travolta. That looks like a winning movie I'd be delighted to see. I have not, but goodness gracious, John Travolta is a real human being on this here planet Earth. Holy fucking shit. Boo! And we also have Miss Enola Holmes, which if you have a daughter and she has not seen this film, you guys should watch it together because it's adorable. And, you know, tomboy, tomgirl, whatever the phrase. The movie's great. I know this girl's name, the actress, and I don't remember it, but she's delightful. The problem. So, we're freaking out about GANs. Why? How is this any different from, like, Photoshop or the fake news that we already have? 2020 has been a delightful year, hasn't it? Said Satan. Glad you asked. I'm glad that you asked the question. The reason is, in short, a bunch of things, but primarily scalability. You know, it's one thing for one country or news organization to have its agenda, which is to some extent fine, and to push it with all their might, with the Soros and the Bloombergs and whoever backing whoever. I do not have a political party. I'm just a piece of shit on the internet. The scalability thing is a longer conversation about computation and gets a little fuzzy. But also GANs, Generative Adversarial Networks, and language models, I'm guessing are going to have some pretty spicy interactions. I haven't seen any research on that. Sounds a little bit complicated to put together, but once you do, you can literally create like a universe, like an open world video game, except it's completely psychotic and reminiscent of the Matrix, where everyone lives in an actual simulation, and reality, what's real, doesn't fucking matter because you don't live there anymore. So, back to the actual point with Mr. Dan Carlin.
You don't even need a large chunk of the country pulling apart. 10% of people who think it's the end times can do the damage. Just like we talked about terrorism before, and a can of gas and a Bic lighter. I've lived in a bunch of places, and I won't give anybody ideas, where a can of gas and a Bic lighter would take 1,000 houses down before you could blink.
Yeah.
Right? That terrorist doesn't have to be from the Middle East, doesn't have to have some sort of a fundamentalist religious agenda. It could just be somebody really pissed off about the election results. So once again, if we're playing an odds game here, everybody has to behave for this to work right. Only a few people have to misbehave for this thing to go sideways.
Huh. Thanks, Dan, but that could never fucking happen. Ho, ho, ho. Yes, it can, and it has. Because the numbers don't lie, and they spell disaster for you. Have you heard of Archduke Franz Ferdinand of Austria-Hungary? May perchance you have, may perchance you have not. Regardless, the fact of the matter is that he was the Archduke Franz Ferdinand of Hungary until at the very moment that World War I started. Then he was no longer. That was a silly and fun way I had of saying that when he was murdered, this aristocrat, World War I began. Is there anything else like that happened recently? King George Floyd? I don't know. All right, so we had these GANs. We need a solution. What the fuck do we do about it? Well, I know of one solution, which is the cybersecurity solution, right? It's your classic protocols with virtual handshakes and whatnot, hence the joke that I put there, where basically as long as you know and trust the source, you're good to go. There's a lot of fake news out there. There's a lot of fake information. It's called most of the shit that's on Facebook and Twitter. But, what comes from the major news sources, that's good. Of course, there's one just tiny, minuscule, completely non-consequential issue here, where you do have to trust the source. So, yeah, we're going to move on from that little jokester to the detection solution, or the Pikachu detective solution, which is more adorable. So, ladies and gentlemen, we found a paper. And I'm very excited about it. There's actually an African-American female who has a YouTube channel. She is a Harvard PhD studying this shit, artificial intelligence, and she seems super spicy. I've forgotten her name entirely. But she did a review, something about GANs and government stuff. It's not what we're doing here. We're talking about some other implications of such technologies. But she mentioned this paper, so I checked it out. This paper's sick, so thank you to her. All right, so what is this paper? This paper is fucking sick. There it is. It's fucking sick. All right, so the title of the paper: Attributing Fake Images to Generative Adversarial Networks, Learning and Analyzing GAN Fingerprints. How do I do this? Oh, my hands. Oh no, my hands got lopped off. There's the link there if you should and do want to go check it out. So, we all have signatures. We have tiny little tells. Sometimes it's rather obvious, as in our first example on the page. But sometimes forgeries are so close. They're not ever quite identical, but they're very, very close. But they're tiny little tells, and that's where the information, the discrimination, the sequitur, I don't know if you can use that word as a noun, but I will, lies. So, GANs have fingerprints too. Oh, the humanity. It used to be, because this subject is not wholly new, although this paper is the first really proposing an actual solution for now of any of the research out there, at least that I have been aware of, is including the references and comparisons they make in this research result as well. So we have the inception feature space, which is basically the kind of data they were trying to, is it fake, is it real, and use that to determine. As you can see from the delightfully colorful little blob here, yeah, no, you can't tell. It's just a whole bunch of mumbo jumbo. But when they looked at the feature space of the fingerprint, we have these nice little chunky blobs that are useful. So, it's a research paper. There's some math. It's very scary. It's okay. Doesn't matter. None of it matters, okay? We gotta, if you can see, hopefully the resolution and frame rate and what have you are sufficient enough to show you that this is a confusion matrix. Woo! The confusion's in the name. So basically, these neural networks, these GANs, when they make an image, they're sort of echoes of the machine, echoes of the architecture of tons of parts, the weight initializations, but a bunch of other nitty-gritty details that are not super important. But those little bitty tells, like a signature, that little loop you do at the end of your E or whatever, but in, vector space, math stuff. And basically, they are able to compare the image to the fingerprint and see, if you can kind of see along like the diagonal in the image, it's a little bit lighter. There's meaningful information there showing that using this sort of delineation mechanism, you can determine which model made this image, and also if a model made this image. Hence, it was not, no model made the image, therefore it's real. Okay, great. So this is an example of the kind of output that they were using. So that this is, none of these people are real. These are all computer generated by our GAN. Nothing untoward or surprising here. Another example where the top set of images, there was no attack. We'll talk about the attack more in a second. So these are just purely generated. Again, none of these people exist. Below, we have the same, I hope you can tell, the same basic set of images, but they add a bit of noise to the image. Question being, if we add a bit of noise, if we do a bit of blurring, sort of really basic image processing stuff, is that sufficient to destroy the fingerprint that we're looking for? Because that's what we're using to tell if it's real or fake. First off, a lot of those pictures looked absolutely terrible, and we should take note of that. And they do describe their neural network architectures in the training time, and they did a lot, like a whole lot of different experiments. So I don't blame them wholly for, because in this area in particular, the more computation you spend on this stuff, you get much better results. You get fewer what are called artifacts, basically stuff that just looks completely wrong. Like at one point, there's a guy who looks like his eyes have like exploded into like bug eyes, and it's because the the GAN wasn't quite sure, are we going to give this guy glasses or are we not going to give him glasses? And so that is an artifact. It's a mistake. And to a human, it's quite obvious. Like, this is clearly fake. Nobody has half sunglass eyes. And if they do, they should probably get that checked out. Okie dokie. So, these are the other, these are a few of the real images. Apparently these are famous people. I don't know who any of them are. But as we can see, they're also low resolution. They're cocked heads. They're, occlusions. I think that's the right word. Nice. So here are the results. Here they are. And some of this stuff is wild. Okie dokie. So they had two data sets. Number one was celebé, also known as celebrities. The second one was living rooms, which is really exciting. They could have done Pokemon. They did living rooms. Not that I have a strong opinion. Okay, so the numbers we give a fuck about are these ones here. The FD ratio is something we don't have time to go over, and it's not necessary. If you're curious, they have an entire equation appendix, but up here, okay? Eyes front, stop looking at the goods. Goodness. Okay, so the accuracy, no, they don't include precision recall and stuff like that, which is frustrating. Whatever, we'll just take accuracy for now. So they compared against some other, KNN is not ever going to do well on this, but they tried it out because it's a classic classifier. I think it's K nearest neighbor, eigenface and PRNU. So these are the baselines. What we really care about is goodness gracious. You were able to determine with their architecture whether or not a GAN, whether or not an image, so you receive an image. Hey, we have this image. Is it real? Or is it fake? Was it generated by some AI? Well, this paper, their code, is able to determine with 99.43% accuracy whether or not that image is a fake image or a real image. If it's a human face. That's awesome. Okay, that's awesome. This is the kind of shit that I'm talking about. This is it. This is a masterpiece. A masterpiece. And if it's a living room, 98.58, which is sick. Enter the caveats. So, we saw earlier that some of the images, they tested again with, tiny blurring, adding a bit of noise to the image. And, in particular, adding some compression. So what happens when you do that? We have our network to determine whether or not it is a real or fake image. And that's all it knows. Now we add in a bit of cropping, and all of a sudden, our result, our accuracy, drops to 46.8%. You know what that means? That's worse than a coin flip, aka it's dog shit. So the question is, if we do some of that little bit, just tiny bitty changes, where a human pretty much looks exactly the same to us, but to these algorithms, does it make any difference? Does it throw that fingerprint we're looking for? You know, that's the thing we're using to tell real or fake. If we do these tiny little changes, how much does it screw with that? Well, let's take a look. So, if we just add a tiny bit of noise, Gaussian noise, we go from we were at like, what, 98% accuracy, 99%, to a 9.1% accuracy, which I'm pretty sure is substantially less than 50% accuracy, because you have two options: true, false, fake, real. And it's getting 9% of them correct. Guessing would be 50%. So something has gone terribly incorrect. However, if we tell our, it's not quite the discriminator, they add like an extra layer, and that's the fingerprint extra feature layer. We're not getting into the architecture details. We're not, even though we just did. Oh, it's a paradox, also known as a lie. If we include to that extra feature layer the sort of extra discriminator, the model they're using in the paper, if we include in that model that we're using noise, that's the method we're using to perturb our image, boom, we go back up to 93%, which is still a loss of, 5-6% accuracy, but still 93% accuracy. It's pretty useful. It's not too bad. Unfortunately, that is not true for all of these, right? Note, so that the DFS, that's when we add that extra layer of like, okay, we know what this is. We know what the attack was. We know that we were attacked by noise. We got the image and there was noise added to it to try and mess with the fingerprint. Because we know that, we can go from 9% accuracy, which is dog shit trash fuck, to 93, which is, homeless, but you're not starving quite yet. And then, it varies for each of these, except for compression. Compression does a number, right? So compression 8.7 is the lowest of our results. And even after we tell our model, our extra discriminating model, hey, we use compression, it still only gets up to 88%. Which is getting into the range of really not very usable. So, and then the most interesting of all is if we tell the discriminator, hey, we used a combination of these. So that it's one of these 5 different options, but we don't distinctly tell it which for each image. We give it a batch, the mix. All of a sudden, we are only able to get up to 72.64% accuracy with a baseline of 50% accuracy. So we're 26% above random chance. Sure. Which is pretty bad. It's not very good. And a combination, compression, these are very, very simple algorithms. These are not really attacks, right? Like, I totally understand why they would use this in the paper, and they're grand and wonderful tests to run. But what is more likely that would happen is, an attack would be handcrafted for a discriminator algorithm. And at that point, if random simple compression and a simple combination of things can do such a thing, how effective is a real attack? I think it is likely that it's pretty scary. So a key point to note on this, combination and compression attack is that it seems that process is somehow really able to to adjust, to destroy the information of the GANs fingerprint, which is the entire point of this paper, is that there's a tell, there's a little signature something behind each of these GAN architectures. Well, if compression is able to do a pretty good job of getting rid of that, and a combination of different algorithms, of sort of noising algorithms can do such a good job, it really seems to me that if one were to try and get around being detected as fake or real, creating fake content, this would be a great way to go, is to really hone in on the fingerprint and try and mess with it. So, 99% accuracy. Oh, it's amazing. We can tell what's real and what's fake. For now. Sometimes, if we're not being attacked intelligently or even unintelligently, it's a little bit brittle. So, what is the structure of the problem that we are trying to solve? The fuck is it? We're trying to tell, we receive some piece of information. In this instance, it is a picture, or a series of pictures known as a video. We want to know, is this real, or is this fake? Did this happen? Was this recorded with a camera, or was it created completely virtually by a computer of sorts? Well, that's tough, because what we just described in the very basic architecture of the generative adversarial network, so it's generative, it's making stuff. It's adversarial, right? We have the forger, it's making the fakeness, and we have the discriminator. These are considered one thing. There's a duality, it's a yin, it's a yang, it's a surreal number. It's a self-play mechanism. I'm currently working on my own research to create a surreal GAN, a GAN that is surreal, because I think that sounds so sick and maybe effective. We'll find out. So the fact that that's just the basic structure of the thing is that any, external feature layer, I was like, oh, well, we made our own discriminator. Okay, well, the only thing powerful enough to kill it is itself. Did I just quote Incredibles? Yes, I did. And that makes me very nervous when, we're looking for some little feature, some little tell. Well, the whole point is that it internally is trying to learn those tells and to learn those tiny little giveaways that, tell it that it's kind of similar to a virus, like a literal biological virus, where the virus doesn't want you to know it's a virus. Cancer's so dangerous because it is you. It has your DNA. And it's succeeded at this game, where the generator has mastered the discriminator, and you can no longer know what is true. And so the sort of new race, species, whatever, comes in and, it kills you. All right, yeah. So, it's an arms race, right? You have the discriminator, and you have the generator. They're constantly at war. Well, if the problem that we are trying to solve is outside of that context, right? So it's having, the GAN is having its own internal struggle at an increasingly faster and faster rate, with maybe increasingly compute power, etc. And we are out here, external from it, trying to fight it. Well, we're always outside of it. So at the very minimum, there's a time delay, and likely many other hidden layer, high dimensionality stuff we're not getting into. But your point is that you're always a step behind. Always one step behind. Minimum one step behind. And if you keep doing that over time, you literally never catch it. It's not a Xeno Paradox Skyrim meme. It is a problem. That's an infinite space. That just means you've lost. That's not very good. We'll talk more about zero-sum games and why I think that they are the great filter. And, the fact that these are an arms race shape is... it's concerning. So let's talk about what I estimate may be a real solution to this sort of problem of finding out what is true information, what is true images or news in general. It's not a detection system, because you have to trust, and good luck. and it can't be inside of the context of this adversarial game. So essentially what I'm stating here is that I don't necessarily know what the problem is, but I do not think that the solution resides inside of the context of a zero-sum game-like structure. To get into an arms race with a generative adversarial network, it's not a good way to go, right? It's the we don't want to fight AI. We lose that war. We want to merge with AI, not fight AI. We lose. We lose that, right? You want to go into a boxing match with Mike Tyson? No, you don't. You don't want to do that. He's going to get an erection and snap your neck. Merry Christmas. If you know anything about Mike Tyson, I sound very strange. Even if you do, I sound very strange. So, we're going to talk more about solutions. So not the final solution. Good Nazi joke. But basically, seems to me the situation's pretty dire with a lot of this stuff. And we're going to have to choose the best of bad options. And we can talk about the advantage function for how to systematically do so. Because we're going to need to. So, I don't have the solution. If I did, I'd write the frickin' paper on the subject. However, there are some really, really competent people who do realize this is a very big issue and are working on it. Funnily enough, Ian Goodfellow, the guy who came up with this stuff, has done very well for himself. I think he is currently the head of AI research at Apple, where previously he was at Google. He worked with Geoffrey Hinton. The guy's a legend. Really, really like Ian Goodfellow. But he's spending a fair bit of time on kind of ways that AI, neural nets in particular, can be hacked, and a lot of just sort of slowing down and let's make sure we don't make something either exploitable or exploitative, which is another option. So what do we do? A little call to action somebody puts at the end of the video. Well, first off, I think research like this is a goddamn glorious first step where we see sort of what is possible and that some things are very possible. Like this is most of the time very effective. You know, when all the parameters are known, minimum result was like, what, 88%? That is way better than not having any mechanisms at all to determine if something is real. So the second is to think hard and fast. Winky face here. You know, is the solution inside of the context of a zero-sum game? It very well could be. I'm very dubious of this, but it is possible. However, I do think we could talk about kernel functions and SVMs and dimensionality reduction and whatever, but much of the time you can do impossible things just by thinking really hard and finding outs that are incredible. You know, calculus is doing an infinite, it's solving an infinite problem. Goodness. You know, they figured that out a few hundred years ago. We can figure this out. So, it's a good example. I like that one. You know, projective geometry does some badass shit, man. Holy fuck-a-moly. Alright, so, GANs, we'll come back to them because A, they're fucking sick, and B, my guess is that fake content is going to ramp the hell up as spicy meatballs like myself and other nerds on the internet decide to do some activism and some trolling because it's fun and or important. I don't know. So, I want to talk about pain and pleasure, but also pain, because what is pain but weakness leaving the body? It's actually not that. Pain is an opportunity to gain information, and gaining information is vital to survival, which is all that fucking matters, which we'll talk about more later as well. So, DeepMind, pointing the wrong way, DeepMind, these guys, just published, it might be in preprint, I have forgotten, but this paper on how they want to synthesize the subject of machine learning. In particular, I think they talk about reinforcement learning and that of pain. And particularly that of the human experience of the sensation of pain, which is fascinating. Also, a lot of philosophers have talked about the subject, and I think it's pretty fucking sick and important to, A, keep us sane in a world full of pain, and not to shy away from it and accept doctrines that demonize something so necessary to our existence. Well, I hope this was fun, and if it wasn't, you're boring. Or you're just bored. This could have been boring. I had fun with it. I had a blast. It could totally fuck us if we don't figure out GANs, like really bad. So, I'd like to thank these human beings for being legends and publishing this research. This is a fantastic paper, very well written, very cogent and clear to somebody who's not quite an expert like myself. Very readable. They did a lot of experiments, which is a lot of work. And also them for being kind of the first to really publish a pretty meaningful work on the subject. So, hurrah. I will not try to pronounce their names, because I'll bugger it. Words are hard. Okay. And did you know? They get paid for their work. I'm not getting paid anything yet. Which, if you'd like to do the Patreon or the PayPal, that'd be cool. I don't know if subscribing to YouTube does anything. Supposedly there's an algorithm that likes you more if you have subscribers. And the whole point of the show is to be liked by AI so we don't get eaten. Why not start now? All right. I like my hair. Goodbye.